Good morning. I am Navaraj, Associate Professor of Fundamental Institute of Technology. Today I am going to deliver the lecture on the topic pin diode. Pin diode is made up of a p-type substrate and an n-type substrate. In between, the lightly doped intrinsic semiconductor is attached. Now let's move on to the introduction of the pin diode. A pin diode is a diode with a wide, lightly doped near intrinsic semiconductor region between a p-type semiconductor and an n-type semiconductor region. The p-type and n-type regions are typically heavily doped because they are used for the ohmic contacts. The wide intrinsic region is contrast to an ordinary pin diode. The wide intrinsic region makes the pin diode an inferior rectifier, but it makes the pin diode suitable for attenuators, fast switches, photodetectors, and high voltage electronics applications. Let's look upon the construction of the pin diode. So the pin diode, which will be constructed with the top layer and the bottom layer, will be provided with the metal contact, and in between we will be provided with the p plus contact region and n plus contact region of both p type and n type. In between the p plus contact region and the n plus contact region, intrinsic layer of larger depletion layer region have been formed. It is lightly doped. The speed of the pin diode is limited by variation in the time it takes electrons to pass through the device. This time spread can be spread in two ways. One is by increasing the biasing voltage or by reducing the thickness of the intrinsic layer. There are two types of pin diode. One is the metal semiconductor pin diode and another one is heterojunction pin diode. Now we will see about the operation of the pin diode. A microwave pin diode is a semiconductor device that operates as a variable resistor at RF and microwave frequencies. A pin diode is a current control device in contrast to a varactor diode, which is a voltage control device. As we all know about it, the varactor diode is a variable capacitor, a diode with a variable capacitor. So as the biasing voltage of the diode gets varied, the capacitance of the varactor diode gets varied. So since it's a voltage control device, whereas a pin diode is a current control device. When the forward bias control current of the pin diode is varied continuously, it can be used for attenuating level and amplitude modulating of the RF signal. When the control current is switched on and off or in discrete steps, the device can be used for switching, pulse modulating, and phase shifting an RF signal. When the diode is forward biased, holes and electrons are injected into the I region. This charge does not recombine instantaneously but has a finite lifetime in the I region, intrinsic region. If the pin diode is reverse biased, there is no stored charge in the intrinsic region and the device behaves like a capacitance shunted by a parallel resistance. Now we look upon the applications of the pin diode. It is used as a photodetector for most fiber optic applications. They are used in electronic preamplifier to boost sensitivity. They are used as a variable resistor in at RF and microwave frequency. It is widely used in RF modulator circuit to control the RF intermodulation distortion. Pin diodes are utilized as a series of shunt capacitor switches in phase shifter designs. The switch elements are either length of the transmission line reactive elements. Now let's look upon the varactor diode. The varactor diode is nothing but a diode with a variable capacitance. It is also known as a varicap. It is a microwave solid state device. It is also called as a parametric diode, tuning diodes, or varicap diodes. It is a non-linear device and it is also a voltage control device. It provides a voltage dependent variable capacitance. As the biasing voltage of the diode gets varied, the junction capacitance value changes. The types of varactor diode: abrupt and hyper abrupt type. When the change over PN junction is abrupt, then it is called as abrupt type. When the change is very abrupt, they are called hyper abrupt type. They are used in oscillators to sweep for different frequencies. The next type of varactor diode is gallium arsenide varactor diode. The semiconductor materials used is gallium arsenide. They are used for frequencies from 18 GHz up to and beyond 600 GHz. There are three most important criteria for the varactor diode. The foremost thing is capacitance. Capacitance of the device, capacitance from a few picofarads to hundreds of picofarad is provided. Capacitance range, the range of capacitance produced when voltages vary. Voltage range, the minimum and maximum voltage that can be applied to the device. Bias current, the bias is always reverse. This means that the varactor diode does not conduct electricity. If the bias is turned positive, then the device will start conducting. Other criteria to be considered include reverse and breakdown voltage, leakage current and junction temperature. Voltage and other transient must be avoided. Transient can occur if the DC voltage is put off. The characteristics of the varactor diode are low noise characteristics. It produces much less noise than most conventional amplifiers. It is low cost, provides high reliability, lightweight and small in size. The operation of the varactor diode is, it has a PN junction of semiconducting material and is always reverse biased. The depletion zone depends on the applied voltage and this makes the capacitance vary with the applied voltage. The applications of the varactor diode are frequency multipliers. It is used in applications where it is difficult to generate microwave signals. It produces relatively high power outputs at frequencies up to 100 GHz. It does not have gain, in fact it produces a signal power loss. Output can be as high as 80% of the input. Thank you.